Good morning, everybody. So my name is Marie O'Donovan. I lead the CoastPredict Secretariat, and I'm going to introduce the presentations of the CoastPredict core projects. So there are four core projects that were designed to align with the CoastPredict focus areas to gather the expertise, the methodologies, and the innovations that will be required to develop an integrated coastal ocean observing and predicting system. So the presentations this morning will be 10 minutes. I want you to bear in mind that there are breakout sessions tomorrow for each of these projects. So there's a session in the morning, there'll be a room per project, so any questions and more in-depth conversation can be had then. So we start this morning with the Future Coastal Climates Flame Project, led by Jason Holt, who had a very productive workshop yesterday. So Jason, over to you.
Thanks, Marod. Perfect, thank you. Thanks, Marod. So I'm going to talk a little bit about the Coast. We're not. There we go. CoastPredict Flame Project. So this is a project about downscaling future climate information to the coastal ocean. So I've listed our core team up there, and there's a QR code, which if you want you can scan, and if you're interested in getting involved in Flame, just either go to the email address on that website or drop me an email, and it's very much a community open to anyone who wants to get involved in, who's interested in future climate information in the coastal ocean. So I'll say a little bit about what we're about. We did have a workshop yesterday, so I suspect a lot of people who are at that are very familiar with the activity in Flame by now. So the starting point is as we're aware, there are continuing developments in the global climate model sphere. The global climate models are making huge improvements in their ability to predict and project the climate system, or many aspects of the climate system at a global scale. But there is still an information gap regarding the coastal and shelf seas, and that's a gap that we don't expect the global coupled climate models to close anytime soon. It's going to persist certainly through the next IPCC process and probably the one after that, I would imagine. And that's really a matter of scale. That's because we have this huge disparity of the scale between the global system and the scale that humans interact on, which tends to be of the more the kilometer, tens of kilometers or a few meters scale. It's helpful to see this as a hierarchy of cascading down from what we can do at global models, maybe 25 kilometers, through various scales of regional modeling down to the kind of coastal scales of a few 100 meters. It's not just about scales. It's also as you cross these divides, new processes become more important. So interaction with benthic systems, with tides, things like that becomes important. So addressing that is really the point of Flame. So we early in the project we kind of mapped out the value chain that you needed to get information in the coastal zone, and we realized it was both immensely complicated in the number of connections, but also in the number of different communities of practice involved. So it brings together a vast range of different practitioners in different areas of science who possibly don't traditionally work together. So there's a huge challenge there. So the objectives of Flame, I mean, I've listed them here, but I won't go through them in great detail, but the one to highlight is actually the one on the top right there, which is I think our real ambition, and this is to establish the community of people working in this space, and particularly looking towards a global coastal ocean model intercomparison project that could itself then contribute to CMIT processes, IPCCs into the future, and that's kind of like the long-term ambition of this work. Another thing to note is it's quite a long way to go. So in a bit of a meta-analysis, we mapped out where coastal ocean studies had gone on in the world in terms of future climate downscaling, and that's shown in this color-coded map by large marine ecosystems down here. And you see that some areas are very well covered, other areas are not. It's a very, very patchy picture. And as I put up this map, I immediately noticed is that we can't even include in our mapping the island states in the Pacific here. So there's a huge there's huge gap even in our representation of where the information we have is that we'll need to address into the future. We started off with a workshop in Liverpool in 2023. We had 60 people there. I seem to remember it was online, it was in person only, so it was a relatively limited community, and we'd hope to be able to broaden that out much further. Earlier this year, we submitted our first community paper. So future climate projections in the global coastal ocean went to progress in oceanography. So that's being reviewed at the moment. And hopefully that will be a good output of this work, kind of charting the strategies for going forward with this. We've had pretty good success in organizing our conference sessions, and a big shout out to Anna Katavuta, who's in the back there, who's really been pushing this. So we've had a session at AGU Ocean Sciences in 24 and also EGU that year. We were involved in the CoastPredict EGU session as well, and we had an online ocean best practices workshop last year, which was actually very well attended online. That was really promising. Okay. No, to advance. I'm in the wrong place. Okay. Got it. Yeah, that's good. Okay. So another thing to note is that we are building connections with other activities, and I think this is really important. The particular one I would like to highlight is the one in the middle there, the cluster of logos around the linking with a new task force on regional ocean climate projections that's emerging from the CLIVAR Ocean Model Development Programme and its link with Cordex. So this is kind of an analogous activity that is coming out of the WCRP activities in terms of climate projections. And so there's an awful lot of synergies that we can build with that activity. Probably taking a different approach. I mean, one unique thing of what we would want to do is to cross the scales down to the coastal scales. But I think in terms of aligning certainly aligning with the Cordex community and learning how they've organized, I think there's a lot to be done there. And last up, we are always looking for funded activity, and Coast Flame itself is doesn't have funds. Everyone essentially brings their own funds to the table. But we have a wide range of national and international projects that are beginning to align with that, and we're looking to expand that as much as possible as we can. So that's all from me. If you're interested in getting involved, do drop us a line. We're very, very open to as much participation as possible. And we'll have a session tomorrow, and happy to answer any questions then, or catch me at lunch. Okay, thank you very much.
Jason. So we move online now. We are going to Miguel Charcos Llorens from the Balearic Islands Coastal Observing and Forecasting System, or SOSIB. And Miguel is going to present the Coastal Ocean Resource Infrastructure System, or the CORIS project. So Miguel, can you hear us?
I can. Can you hear me?
Hi, good morning.
Good
Are you
morning.
going to
I'm going to share the presentation. Can you see the presentation?
You can see the slides, just presentation mode. Yeah, perfect. Thanks, Miguel.
Excellent. So I thank you for joining today, and I just want to refer to one of the comments that Richard said in the video from Nadia, that in order to achieve our goals in CoastPredict, we need scalable solutions, expand cloud-based computing, and enhance accessibility. And I will add enhancing capabilities as well. And this cloud computing can do that for us. In fact, that's the purpose of CORIS, the Coastal Ocean Resource Infrastructure System. And I'm representing a large group of people today. And CORIS is not just a standalone initiative, but it involves a few other projects because we don't have funding. So we try to find opportunities in these projects. And through these projects, such as Blue Cloud, OSTRES, and in particular Jericho, we are trying to make this interoperable through the European Open Science Cloud, EOSC, in order to guarantee that the data is fair. And in today's presentation, I will remind what is CORIS, the goal of CORIS, and also the vision of CORIS. What is the roadmap in the next years? I will present the CORIS service infrastructure, from the infrastructure that I presented last year to the current solutions that we have today. And in particular, I will talk about a few of them, a few of the work that we had done and the status of those. So let me take a moment to revisit the fundamental aspect of CORIS. So CORIS is a system that will allow data and service integration in order to transform this data into actionable knowledge. So it's also a knowledge and information system, and it will provide also a collaborative environment to allow researchers and institutions to facilitate the work and the interaction. And the fourth leg is the resource and impact assessment, so we can evaluate what are the different activities, what are the outcomes from all these activities, and to monitor these processes. And we have to remember that this project comes from the Jericho community. It happens that in Jericho Next, we identified that we needed a digital ecosystem for supporting the European coastal research. And in Jericho S3 project, we created a pilot with Jade, that is in the room, so in case you have some questions, to investigate, to explore the needs of the people, or the stakeholders, to explore the different technologies that could be used. And that was expanded in Jericho Design Study to make it more sustainable, for a more sustainable research infrastructure for coastal observation in Europe. And to fill the gap, we participated in a few other projects, such as Blue Cloud. In Blue Cloud, we are trying to integrate the different components that we created for this pilot, and to apply this to specific cases. And in OSTRES, we're going to expand this to, we're going to improve the data model. We're going to improve the assessments that we create in Jericho S3, and we are adding some functionalities such as the machine actionable data management plans. And all these can be applied also in the context of CoastPredict. And from these experiences, from the requirements that we collected in these projects, we elaborated this roadmap that I presented last year. But I just want to point out that for the near term, what we need is a very good foundation, a strong infrastructure that can support all these functionalities that are in this diagram. So the goals for the next decades for the next years are to create this infrastructure and make it available for the global coast experiment sites. And this is the diagram that I also presented last year. It's a little bit fine-tuned with the experience that we had this year, but you probably know that we're gonna be based on the EGI cloud computing. And the idea is with all the observations that are collected by the global sites, all the models that are provided by them with the help of GOOS, of course, will be integrated in this system. There will be some services such as a science knowledge graph that will be interconnected with ODIS. There will be the support for data management plans that are automated, and we can monitor this with assessment tools that are provided. So this is a high-level infrastructure that we fine-tune a little bit with specific technologies along the year. And these are the technologies that we identify that can be useful and we need to explore. These are very dense diagrams, so I don't expect you to see to look at the details. Probably you cannot even see what is written there. But just I will run you through this diagram. At the top part, you can see that the observations go to the produce data that is managed in this data lake environment. There will be some pipelines to manage the data flows. There will be storages. There will be distributions as to different technologies. And these will be used for modeling and other advanced products that we can produce in the context of CoastPredict. So this is the typical data value chains that we have in many of the projects. So what we propose here is to include this integration and interoperability layer that will facilitate the elaboration of the tools for this data flow. So, for example, we will have a blog to produce and deploy and monitor these deployments and the developments of the software. We'll have tools for data traceability, and we will have services where users can go and play with the data even before creating like automatic pipelines that manage this data and transform this data. And the part I like most, which is the one that we are deploying under OS Trace, is this block here that contains a lot of components to identify the digital objects that are used along this data flow, and to assess the data flow, these digital objects, and overall create the data management plans that define how the data flows along the value chain. And of course, it will also interoperate with international infrastructures in both directions. It will collect information that is needed, for example, best practices for the ocean best practice to be used at different stages of the data flow, but also it will provide the information about what assets are used along the data flow to these different infrastructures. So how this fits in the fundamental principles that I presented at the beginning. This summary is mainly what I just explained. There will be tools for collaborative developments, such as virtual research environment and the development tools. It will be tools for data management at the top and data traceability and data management plans, tools for assessments, a catalog, and this will be interoperable with the infrastructures, as I just mentioned. So what do we do to move this forward is in the OS project, we are creating these components, which is basically the ones I showed you before at the bottom right corner. And we are using the interoperable framework defined by the OS Trails that will be interoperable with EOS. And so in that case, it will be interoperable with other disciplines that may be used for other purposes, such as digital twins, when I include, for example, economical inputs. So in the context of Blue Cloud, we are creating this data flow for glider data. I'm not going to go into the details because close to my time, but my hope is that we can merge together the outcomes from both projects and take the OS Trace components to manage and monitor this data flow. And in a side project that was done by a student 2 years ago, we explored how to use new technologies such as blockchain to decentralize the traceability and to guarantee the integrity of data. So in conclusions, I think we are well advancing in exploring the different blocks of this architecture. There are ongoing validations, a few projects and that are running, a few projects that happen. But looking forward, what we need a sustainable funding to accelerate this process. We need to explore technologies. There are a lot of technologies that can be used, especially in the private sector, that we need to play with. So to make sure that are fitted for our purposes and expand capabilities, for example, for digital twins, and of course for engaging other communities such as indigenous and local and citizens. Thank you.
Thanks a million, Miguel, and thanks for the beautiful timekeeping. There was a lot of information in there. Tomorrow morning, the CORIS breakout room will be led by Jay Perlman with Donatello Elia. I'm sorry. And Miguel will join online, so more questions can be fielded then. Next, we have Predict on Time, presented by Giovanni Copini from CMCC, who will speak about the work on multi-hazard people-centered early warning systems.
Okay, thank you. I will introduce you to the progress objective. Hello? To the progress of Predict on Time core project. We deal with the short-term component of the integrated ocean coastal observing system and predicting system. So our vision is to improve the observing and predicting capacities for the coastal community, but also to make it relocatable in order to answer to some of the questions we raised this morning on how to serve the larger community, how to model and train people, enhance their capability. So simplified but develop sophisticated system to relocate our modeling capacity and the observing system to make it cost effective to integrate in an observing and forecasting system which entirely will be relocatable. And the final impact will be to minimize the impact. So the final objective will be to minimize the impact of the extreme events in support of coastal resilience. The high-level objectives that you can find here are to improve the understanding and the predictability of the coastal ocean, including also the relocatable system, to develop a method to integrate and exchange across observing system and towards the prediction value chains from observation to services, and to innovate and develop innovative sustainable application that now we call solutions, and we will discuss this afternoon about that, and of course contribute not only to the predicted one but also to the safe ocean. So it's a community, it's an open community as Flame and the other projects, and we are leading it together at CMCC together with the NMEFC in China and Eurogoose. And then we have more than 60 partners from 35 countries. And I think it's a good community. We haven't been able to, let's say, to keep the community so together, and maybe this is a weak point of Predict on Time, but after the workshop we have been focusing on the survey, and it was quite successful, and I think we are developing synergies through training, exchange, and projects among this partnership. We have been luckily in funding with Focus, which, let's say, was developed, which is an Horizon project we'll discuss, will be presented by Joanna Staneva will be discussed further, so I don't give details here. But as you will see in focus, there is a lot of the research development in the European community on short-term, on observing system, how to integrate them, how to link with the river, the hydrological component, and how to develop, for instance, also data simulation and short-term forecasting. So I think it's a good contribution. We haven't been lucky with the cost rise, which was a CSA dedicated to Africa. We were a bit too much optimistic. We prepared it too fast in too short time, and we were unfunded. But instead, we have been very good, and we got CS Match 1, which is an Horizon CSA dedicated to citizen science. So we'll, let's say, really expand our capability in the cost-effective in situ observing system. Again, it's a European project, so it's not enough. But I think it will put the basis. You have here Viviana Piermattei, which is the coordinator from CMCC, but also Patrick will mention it because the CS Match 1 is contributing to the decade action called Scopus that will be presented later. And we have been contributing, I will use a few slides from Nadia. We have been contributing to the Ocean Decade Vision paper on increase community resilience, which really has defined the concept of a people-centered multi-hazard people-centered early warning system, which I think we predict on time focus on that, and I think will be our really initial base to further develop. As most of you, we are contributing to the menu, the global cost menu of solution we will discuss this afternoon, and also to the adaptation fund proposal, which will, let's say, complement. The very interesting analysis, this is not new, but updated, is that most of the pilot focus on the impact area 1, which is related to the capacity in disaster risk reduction and real-time forecasting of extreme events, here highlighted in red. And the three of them highlighted in yellow are the one we will focus on with the adaptation fund proposals. So I think we'll, let's say, expand our capacity. I think the yellow one shifted a bit on the left in the Caribbean. So one is in the Caribbean, Philippines, and Southwest Pacific. So as said, we focus on impact area 1, and I think our key step forward is to move from or to further develop and test the components and then integrate them in the multi-hazard people-centered early warning system concept and demonstrate it. So just a few slides on the Ocean Decade paper, that vision paper that is available online, is published this year thanks to Nadia and all the colleagues. One important aspect is that it includes also the tsunami aspect, and I think we should really, in Predict on Time, expand a bit more on that. And as you see on the left, the outcome 1 is really what we are working together as a community for the design of the people-centered multi-hazard early warning system, which characteristics are the stakeholders' engagement, the responsibility sharing, the accessibility and communication, and the institutional capacity building. So more and more we need to enforce this focus. Of course, with also the aim of supporting the design and adaptation planning strategies to increase cost resilience. Here you have the different component that has been defined in the paper of the ocean and coastal hazards, and you see most of them are very relevant, if not all, to predict on time. So it's a very good best practice definition, I'd say, and the different steps are clear from the observation to the modeling to the hazard mapping that I think we should focus very much. Also, for instance, the wave and the storm surge hazard mapping should be a product included in what we will develop as a cloud available for everybody. and then develop toolboxes that will allow the accessibility, expand the accessibility. So next step, and I will conclude, we will continue, of course, to support the contribution, to support the preparation of the adaptation fund proposals that are in the pipeline, the 3 of them. I think we will continue to consolidate the collaboration with the other program instead of CoastPredict, the co-design program of GOOS, which is important because connect us to other community. There is they call it exemplar. So there we are represented through Predict on Time with the storm surge exemplar, but there are other exemplar on tropical cyclone and on marine heat wave that are clearly close to Predict on Time and to CoastPredict. And I think we can benefit out of this collaboration. Finally, I think it's the time, actually we are late and I will push. I already said that last year, so I will commit to prepare a paper that will gather our Predict on Time community expertise and capacities and describe where we are, where we want to go. And then I think, not in parallel, but as soon as we have done with the adaptation fund proposals that are in the pipeline, we should focus again on Africa and maybe South America and maybe more, but at least these 2, in my mind, comes as very important. So if you want, of course, as Flame, CORIS, and the other projects, core project, this is a very open community. And here you have my email and my red one, and you can email us to join. Thank you.
Thanks, Giovanni. And now I'm happy to welcome Godwell Namo from the University of South Africa, who will present the project Restore Our Coasts.
Good morning, everybody. I'm happy to be here, seeing some of the faces I always see online. We are based in South Africa, and I'm one of the partners implementing Decade Action number 4.2.5, Global Coastal Ocean Restoration and Resilience. Code name is Restore Our Coast. And what is interesting about this project, we have got a number or maybe cluster of projects that are being implemented by a number of partners. We have the University of South Africa, where I am based. Thanks. University of South Africa, where I am based. Then we've got Heroin, we've got CMCC, IGP, Plakun, and of course, those are the countries where some of these institutions are based. Now, the countries and ocean basins in which the Decade Action will be implemented include these countries, but the ocean basins: North Atlantic Ocean, South Atlantic Ocean, South Pacific Ocean, Mediterranean Sea, and others. So these are actually part of the ocean basins in which we are going to be implementing the projects, or some of the projects are being implemented. So what is basically Restore Our Coast? Restore Our Coast Restore Coast implementation commenced on 1 May 2024. And will end 30 April 2030. And I'm sure you understand why it's going to end 2030. Restore Our Coast addresses coastal restoration and resilience historically by delivering new solutions for ecosystems restoration and management. And this will be done through a multidisciplinary approach that integrates in situ observations, use of numerical models for forecasting, economic analysis, and project social impact. The approach will inform the application of site-specific nature-based solutions such as coral reef reintroduction or restoration, seagrass and mangrove restoration, passive restoration measures removing sources of disturbance such as the establishment of marine protected areas will also be considered. Now, as part of the global movement, co-design and continuous stakeholder and user collaboration at pilot sites in more than 14 nations remains pivotal. It's central to what we are doing. And private government and community representatives will be engaged accordingly. Now, the projects are being implemented in several coastal areas where partner restoration projects are currently underway and being commissioned, including Renovate. This is a project in north of Rome in Italy, this country. Mangoga, which is a project in Ghana. Placun test site in Spain. The Mediterranean Blue Forest, with the project that is in Greece, Turkey, and Tunisia. 5 coral reef restoration sites in Puerto Rico. We also have got a new site that has been identified in South Africa. I'll talk a bit about this because that's where I am resident. Now, what are some of the things that we're aiming there? There are a number of SDGs that we are hoping to address. Among them, SDG 11, I left there 14, which is pivotal, it's on top, 17 and 13, which is on climate action. Now, what has happened, one of the youngest project we've put on board is one where we are setting up in South Africa in a metropolitan called Buffalo City. For those that are not familiar with South Africa, we have got 8 metropolitan municipalities. Maybe some of you have been to Cape Town, have been to Durban, have been to Joburg. Those are some of the metropolitan areas. But we've got one called Buffalo City that is in the eastern part of the country in a province called Eastern Cape. And we are, of course, in the Indian Ocean. Now, what we've done there, we have gone in February last year to co-create a research agenda with the local community, actually with the municipality and other stakeholders. So we spent a week there designing a program, not a project per se, a program that is going to align with Restore Our Coast. So that program, by the end of the week, we codenamed a Smart and Resilient Buffalo City. So in the Smart and Resilient Buffalo City, we've got a number of work packages for those that have done project management that are going to address a number of projects from loss and damage to mangrove restoration, blue carbon, climate mitigation, fisheries, coastal agriculture, dealing with storm surges, flooding, sea level rise. So there are a number of these work packages that we have set. And among those work packages, we have set a program or a project, not basically a project. And this project that we are actuating now is a project that is going to look at net zero emissions and climate resilient wastewater treatment works. So it discover maybe for those that are from emerging economy regions, there is actually a global problem in terms of how do we deal with wastewater treatment works or wastewater management in general. So we've seen a rapid increase in urban populations, and that is actually causing a huge problem in terms of how we manage wastewater in these coastal cities. So what we've done there in terms of our wastewater treatment works, fortunately now, I think for those that have set a research site, we discover there's a lot of admin work. So last year, we actually spent the entire year trying to establish the admin part, getting permission from the municipality, and also dealing with other stakeholders. Now it's all clear. They've even given us a site in terms of where we can implement our net zero emissions and climate resilient wastewater treatment works. So in this project, we have set a number of outputs or outcomes we want to see when this project is fully commissioned. It's a mega project and it's going to require a lot of money. Number one, it's involved government or local government and also national government. Number two, it involves the universities, a number of universities. We've also brought in a number of other universities, about 8 universities when we went to the site. So what is that we are looking at there? We are saying we need to address about 8 key fundamentals. Number one, we want to have a full automation of this wastewater treatment works. We want to have installation and generation of renewable energy, especially solar and mini hydro, biogas. We want also to have effluent. We want to close the loop, basically have effluent recycling for industrial and domestic use. Mercedes-Benz actually has a plant there that is manufacturing in East London, which is one of the ports. Climate risk and vulnerability assessment leading to climate resilient systems, including baselines for loss and damage. What we are facing there is when the disasters strike, one of the major entry point is around attribution. So I'm saying there, even the national government or other agencies say, we want to know what was the original baseline of this infrastructure before this happens. So part of the bigger project, we are also trying to have a geocoding of infrastructure, developing status in terms of baselines for the entire municipality. We are also looking at harmonizing of scientific, traditional, local, indigenous, other forms of knowledge or knowing. You discover what is happening. There's a lot of maybe conventional scientific information that is taken into coastal resilience, ocean observation, but there's also a sector of knowledge that is not being brought on board fully. And this is actually the idea of local, traditional, and indigenous knowledges. We are also trying to explore digital twinning possibilities. When we are talking about digital twinning possibilities, we always believe that there is a lot of interaction between the coast and the hinterland. And for example, when we're talking about ocean literacy or ocean education, people are quarantined to believe that it should be the coastal communities that should be engaged in this. And we are saying, when you do digital twinning, we can actually bring the ocean into the hinterland. So part of the work we're going to be doing, if we get funding, is to have this idea of digital twinning. Then we want to investigate potential for carbon credits and trading. For those that follow the Kyoto Protocol, there is actually a lane for potential carbon credit and trading. And we hope maybe we can investigate. And lastly, we are also trying to address the circular economy, which is SDG 12. So there's a lot of talk around the circular economy. And we are saying if we can set this project, we are going to be able to restore our coastal community, not only in terms of fisheries, in terms of other issues surrounding that entire smart and climate resilient Buffalo City, but also in terms of this particular project, which we think should harness a lot of other elements coming to the project. In conclusion, the University of South Africa, as the lead partner, looks forward to an exciting period of implementing the Decade Action Restore Our Coast. And we are also, every effort will be made to enhance the growing partnership between and among implementing partners. Of course, the new sites, as I've said, are being established. And I heard Nadia, maybe you're talking about maybe pilot sites. This is one of the pilot sites. And I want to invite everybody who is interested. What we have now is a site. We've been given the entire municipality, which has got a coastline and the hinterland. And what we need actually is to set up some of the projects that we've identified in our program document. And I've heard about CMCC, about the low-cost citizen science technologies. We are excited to hear about that, and I hope we are going to partner in trying or in piloting some of those technologies in South Africa. As I conclude, I want to maybe highlight another initiative that I'm involved in, which I think maybe Nadia and Tim might want to. I haven't heard of it being spoken by my predecessors that were here. Is the All Atlantic Research and Innovation Association. So we are also part of, I actually represent the government in that arm. So we were in Ottawa in October, and they also had almost like a general assembly. So there's a lot of work that is also taking place in the All Atlantic Research and Innovation Alliance. And in the All Atlantic Research and Innovation Alliance, we've identified two key projects. One is coastal resilience, and the other one is ocean observation. So these are actually the two programs that the All Atlantic Ocean Research and Innovation Alliance has identified. So I'm seeing synergies that maybe we could come together. I'm not sure whether there are some in this gathering that are involved in the All Atlantic Research and Innovation Alliance. And of course, the other interface is IORA, Indian Ocean Rim Association. I'm not also sure if there are other people that are in the other association as well. I will pause here. If there are any issues, I will be happy to attend to them as we go for tea and other sessions. I'm going to step out a bit because I'm also presenting in the school in between 1:30 and possibly about up to 4. Thank you so much.
Thanks a lot, Godwell, and I'm sure many people will be at the Restore Our Coasts breakout room tomorrow. We want to grab a photo,